Amazing. All right. When I was starting to learn Ethereum, a lot of resources were thrown at me, and one of them was speedrun Ethereum. Anyone heard about that? Speedrun Ethereum? Oh wow, lots of hands today. Uh, we are so proud to have one of the creators and contributors of Speedrun Ethereum, Austin Griffith. Please give a round of hands for Austin here. So Austin is going to take a train the trainer session with you all. We're just setting up some slides, and he's going to be right here.
There we go. Check, check, check. Hey, how's it going, everybody? I'm Austin Griffith. Thank you for being here. I think the goal is that up. Hey, there we go. It was there for a second. So the goal of my talk, and I think it was titled Teaching the Teachers. The goal today is to talk through how you can take Ethereum and bring it to your university, how you can enable others to teach, and just kind of like going through my curriculum and how I go about teaching. So first of all, we have tour.ethereum.org. If you go to tour.ethereum.org, you'll find our tour dates and information. Specifically, if you want us to come talk to your university or you would like to interface with us, there's this email address down here at the bottom. It's probably really tiny, but it's university@ethereum.foundation, and Shyam will be on the other end of that. That guy right there, yes, yes. So if you are looking for Ethereum to come to your university or come talk, we would love to do that. Talk to Shyam and we'll figure out how to do that. But kind of on another level of abstraction, Denver set my talk as teaching the teachers. And I was like, what's that mean? What do you want me to do? and it's basically, let's go through my curriculum and go through how I go about teaching. So let's do that. So normally I would start just like with the what, right? The ethereum.org website is usually where I would start. And we would go through kind of just like, what is Ethereum? I'm guessing most people here kind of know what Ethereum was. How deep Vitalik just went when he was talking about, consensus and RISC-V and everything. I'm assuming that y'all know that it's like a smart contract platform. It's backed by a blockchain. Usually the points that I try to give people are sort of like, why would you use a blockchain to secure things? And I think the two major things that I try to teach folks is that, one, you get censorship resistance. So censorship resistance would be like someone can block you from using their app, someone can shut you off, someone can deplatform you. When you build an app on Ethereum, no one can censor you at all. And the other piece is just it's tamper-proof. Basically no one can change what has already been deployed. So if you deploy a smart contract app correctly, not even you can stop it. And there's kind of a power to that. So when you deploy this app, not even you can stop it, no one can stop it. It's always going to be up. He talked about kind of there was a period there in like 2016 when it was just like expensive to get to, but technically Ethereum has never gone down. So when you deploy an app on Ethereum, it never goes down, and it's always available to everyone. And so then the next thing I usually do is help them get a wallet. So depending on what wallet you might use, MetaMask is a very popular one, but I like to show people Rainbow just because it's like a very accessible wallet. Just a show of hands, how many people in here like self-custody their own crypto? Like maybe almost half. That's pretty good. That's pretty good. Yeah, and what that means is basically you have control of the private key. It's not living on an exchange somewhere or a non-custodial place. So that means you probably have a 12-word seed phrase. You wrote it down and put it in your sock drawer or something. And I try to talk through this with folks. Basically, if you have a 12-word seed phrase and someone else sees it, your money's gone forever. If you have a 12-word seed phrase and you lose it, your money's gone forever. And this is a hard thing about self-custody. And I try to teach people through how to go about doing this kind of 12-word seed phrase thing. Some people keep it in password keepers. Some people keep it in, sharded and buried in their backyard or something. You can be creative, but just make sure that you can also recover it. Go through the work of, okay, let's pretend like my phone just went in the toilet or my laptop just went in the toilet. That'd be hard. That'd be a big toilet to fit a whole laptop. But let's pretend like my laptop disappeared and I had to figure out how to, go get that 12-word seed phrase, put it back into my Rainbow wallet or whatever wallet I have and make sure I can recover it. So teaching folks how to custody crypto, and really the best way to do it, if you want to, is to send someone like $10 on a like a quick wallet or something, and then all of a sudden they're going to be like, what the hell is this? What, I want to do more with this. I want to learn about this. And then, tomorrow it's worth $8 instead of $10, and then one day it's worth $100 instead of $10, and then they really start paying attention. But the first when I'm teaching, it's kind of just like the what is Ethereum, smart contract platform, decentralized apps, why decentralized, what you get out of it, then kind of how to custody, how to hold your funds. Usually I go then into like a Gnosis safe. So kind of as we've been talking about this whole self-custody being a hard thing, what you probably want to do is look at getting a multi-sig. And so then you could have something like a hardware wallet, your Rainbow wallet, and then like your friend's wallet or something like that. And you need 2 out of 3 signatures to make that work. So how many people in here, use a multi-sig to hold funds? Okay, a lot fewer. If there were a lot of hands that said they self-custody and not a lot of hands that say they use a multi-sig, if you have more than like a couple $1,000s, you should probably look at getting a multi-sig. And that would be that, the same security you have on your one crypto wallet, like multiplied greatly by having multiple wallets. And if this one goes in the toilet, it's not gone forever. I can basically use the other 2 signers to recover it. So this stuff is a lot less sexy than what Vitalik was talking about. He was talking about all this cool academic stuff and how L1 is going to scale. This is more like how to actually use it. And we'll get into like building apps and what kinds of apps work here. But this is the real stuff. This is how you hold crypto. And he definitely has a Gnosis safe. I guarantee it. And I bet he has some really interesting signers on his Gnosis safe. Okay, so we know kind of how to hold it. Start with like a Rainbow wallet, do some cool clicks here to get some, oh yeah, that's fun. And then you may probably have it on your mobile, but also you can get it a browser extension. And this is what you use to end up interacting with a lot of apps. And we'll get to how to build an app in a little bit. I don't know how I'm going to do it with one hand though. I think we'll have to maybe just not build anything. Okay, so what kinds of things? Once you have a wallet, once you have some ETH, once you can send money around, right? We talked about cross-border payments. What kinds of things are actually working on Ethereum? And that's when I like to get into Speedrun Ethereum. So Speedrun Ethereum has a ton of things that have product market fit within Ethereum, and they teach you how to build those things. So if you are, that we were just talking about a multi-sig, this is a very simple multi-sig, and this teaches you how to build your own. If you are a developer, you can go to speedrunethereum.com and you can get the speedrun of the curriculum. And we've done a lot of teaching. We get on a lot of Zoom calls, and we teach individuals, classrooms, all sorts of walks of life. And really, we've just learned a lot from teaching. We've learned how to teach and what kind of curriculum really resonates with folks. And we've condensed that down to a speed run, and that is what Speedrun Ethereum is. So the first challenge is pretty simple. It's kind of outdated now. NFTs used to be really hot. Now more think of it like credentials, right? I think credentialing is something that we'll see a lot of things happen on chain. I think if we were to look at like what is the most simple use other than sending money around and ERC20 tokens, you see like canonical records. People put like PDFs on chain, and then you can just go to the chain and ask any node, what's that PDF? And it'll say it's this hash in IPFS, and you can go there and get it. So canonical records, attestations, just basically like signatures on chain or attesting to some information. But then credentials, I think, is probably like the third most important product market fit there. And you can mint this little Buffalo, which is could be a little credential into something. Maybe you want to token gate something. That's kind of like one of the first easy use cases. And you can do that on Speedrun Ethereum. So challenge one really gets into the heart of the types of things that you put on a blockchain. It's a staking app, and it's not like staking is in like validating and building blocks on Ethereum. It's more like a coordination game. So when you're building something on Ethereum, you need to realize that you're building for a massive multiplayer audience. And I mean massive like global. Everybody can get to it. It's always online. It's funny, when I was first building games for Ethereum, when lots of people started using it, I was like, oh my gosh, this is a different kind of scale than I expected. And there were like all these little boats in the world. And there were so many people that played it that like, it looked stupid because there was just boats everywhere and you couldn't even really tell what was going on. And I think this is a good analogy for what it's like to have a smart contract that actually gets used. It's going to get used at a massive scale. And at this massive scale, humans one-to-one like can't trust each other. And that's kind of like going to get to the heart of these kinds of things that you're building here, is you're building apps for an adversarial group of people. So if we think of trust, if we were trying to get everybody here in the room together to chip in $10 to go buy, I don't know what we could buy with $10, but let's say we were going to go in on buying something fancy and all of us had to chip in on it. Maybe we could trust within this room, right? Maybe we all trust Denver. We could all give Denver the $10. Denver could act as the escrow. But the thing I try to teach folks is that, like, at scale, that's going to fall apart. At some point, you can't trust everyone in this room, and at some point, someone's going to hit the button to defect and steal everyone's money. And you have to just assume that's going to happen, and you have to build systems that can work for an adversarial group of people. That's the kind of thing that you use a blockchain for. And so in this decentralized staking app, you just build a simple state machine that basically says there's a deposit period and everybody can deposit their $10. And if we get enough money together, then we go to a success state where we coordinate to go buy something. If we don't coordinate, there's kind of a failure state, which even in a failure state is just the withdraw state. Basically, people can get their money back. And that's a critical piece here, is like you never lose your money never gets locked up. You're basically building apps for people to coordinate with other people they don't trust, and they can guarantee that they're not gonna lose their money. Basically, the smart contract is gonna do exactly what the smart contract is programmed to do. No one can change it, no one can stop it. And that's kind of the key here as we get into a lot of these. The token vendor, you'll build an ERC20 token, but then you'll sell it on an exchange. And then there's the dice game. You learn about randomness, how public deterministic blockchains are really bad at randomness. It's kind of a hard thing to do. In the early days, people used the previous block hash, which has a lot of entropy in it. It's a very nice form of randomness, except that you can attack that randomness. And you learn how to do that in this dice game. Basically, there's a dice game you can pay. It uses the previous block hash for a dice roll, and if it rolls a certain number, you win. And what you can do in the game is you can create a smart contract that already knows the previous block hash and will only pay to roll in the game if it's going to win. And you'll build a nice little attacker contract. And that gets to the DEX. So the DEX is the hyperstructure, which is a kind of a cool term. How many people in here have heard the word hyperstructure before? Yeah, cool. Okay, so it was like Jacob from Zora, I think. But check out a hyperstructure, a really neat term. We'll get to it in a second. A DEX is basically an exchange, a decentralized exchange. So we've got tokens, we can send them around. Now we want to swap a token for another token. You can always do this in an escrow contract, over the counter, in many other ways. But to do this in a fully decentralized way, what you need is basically reserves of both tokens. And so Hayden created Uniswap. It's kind of the best example of this. At the time, there were exchanges that had order books, basically. And even though they settled in smart contracts, those transactions were coming out of databases. So you had a signed message that said, I will give you this much of this token if you give me that much of that token. You have makers and takers. Someone would find that. They would pay their token and get the other token back. So you could do exchanges, but you couldn't do them in a fully decentralized way. Going back to decentralization is great because it's always on and no one can stop it. Those centralized exchanges had centralized points of failure, centralized points of censorship, and those showed through. A centralized exchange would go down. Maybe it's only for 10 minutes a year, but a centralized exchange still can go down. A decentralized exchange doesn't. Uniswap has never gone down, right? And so let's dive in a little bit to the structure of Uniswap and what a swap does. And it's basically you have these reserves of each token. So you have a whole bunch of token A, a whole bunch of token B, and you can trade them at basically the ratio between the tokens. And what makes this swap work really well is having lots of reserves. So the more reserves in the contract, the better the swap is, the lower the slippage. So what's really interesting there is if you want to make a DEX work well, you need to incentivize liquidity providers, the LPs. And to do that, basically you create a fee and you say every time someone swaps from token A to token B, we're going to leave behind a little bit of one of the two, and the people who are providing the reserves will get paid. And so this is really like the key aha moment you should have with a DEX, is that when you deploy a DEX, you're just writing the rules and you're putting this kind of vending machine out there for people to use. And there's multiple parties. There's the liquidity providers that are providing the reserves, and then there's the people who are coming in and swapping. And the key thing here is that they're incentivized. You're creating incentives. You're not just writing the correct rules, but you're writing the rules with incentives baked in to have the right behaviors happen. And this is kind of the kinds of things that you're going to build on a blockchain. They need to be massively multiplayer. They need to be coordination mechanisms, but there needs to be baked in incentives that get people to do the actions that you need. If we were thinking of a candy machine out in the hallway here at the university, imagine a blockchain version of a candy machine. Basically, if I'm the deployer, I'm just going to put the hardware out there. So just the mechanical candy machine goes out there and I deploy it, I put it out in the hall, and it basically has these features that allow anyone to put chocolate and money in, and anyone else to come over there and put in their money and get chocolate, or in this case, put in your chocolate and get money. That doesn't really happen a lot in vending machines, but this idea of this vending machine that anyone can LP into, anybody could provide chocolate and money, and they can earn fees on their chocolate and money, right? And this is what you're going to be building on a blockchain. You're going to build these sort of permissionless vending machines that allow people to coordinate, and you're going to need to bake the right rules in, but also bake in incentives that allow people to work together. So going on with Speedrun Ethereum, we get down to the over-collateralized lending challenge. And this really gets into the fact that nothing is automatic, okay? So when we heard DAOs, decentralized autonomous organizations, they sound like these organizations that are automatic, that do things automatically, and that's really not the case. everything on Ethereum has to be poked, right? It has to be a transaction. Someone has to do the transaction. So in the over-collateralized lending, there's a whole bunch of concepts to learn here, but basically if we're thinking of tokens and we're lending those tokens out, you have to have $200 of collateral locked up to be able to borrow $150 of some other token because you don't trust everybody. But what's important here is there needs to be a liquidation mechanism, meaning that if my collateral is ever worth less than the amount that I've borrowed, the whole protocol is underwater, and that's very bad. So if you're building a protocol, you need to make sure that never happens. So to do that, you basically say, what is the collateral value and what is the loan value? And anytime it starts getting close, you allow anyone in the world to liquidate it. You basically create a function in your smart contract that says, sell all the collateral only if it's in this certain condition when the collateral has been, is starting to get underwater and it's basically not worth as much. You allow anyone in the world to liquidate it. And this is how you create kind of like an automatic function, right? It's not that it's automatic, but what you're doing is you're allowing anyone in the world to do it and you're incentivizing them to do it. They'll sell off the collateral and they'll get paid to be selling off that collateral. So there's thousands of parties all over the world running open source code, and at any moment they could make money running that code if your loan goes underwater and they need to liquidate you. And so anytime you need something to be automatic on chain, you basically build in the incentives correctly and those actions will happen automatically with as long as everybody knows about them and it's open source and everything. So lending, borrowing, like all this other stuff that has to happen and all these other mechanisms that you need to work can't just be your server at home checking in and running something. It's got to be a system where thousands of parties all over the world have the ability at any time to liquidate the loan. And so even if your computer is down at home, someone out there will poke the button and make the liquidation happen to make sure that your protocol stays above water. Then with that same mechanism, and then adding in some other things, you'll learn about how to do stable coins. Prediction markets, again, are kind of like two tokens with the promise to rug one of them for the other one in the end. So you've got tokens and oracles, and that makes a prediction market. Usually I like to show poly market just to see like some fun market, but prediction markets have a lot of product market fit right now, especially during the US elections. We saw a lot of interesting information come out where the election in the United States was actually, you could call it. You could go to Polymarket and see that it was done. But news agencies are not, incentivized to do that. They want to keep you watching commercials and keep you on the line. And so prediction market is just a way to get to information quicker by having people kind of have their money where their mouth is. Usually there's one on here that I'd like to show, and I can't find it right now, but it's like, will Taylor Swift be pregnant by the end of the year? it's like 50%. Let me see if I can find Taylor. Yeah, there she is. Oh, it's down to 14% now. It was 15% yesterday, yeah. And so this is a live market though. Like you could be betting on this and it's changing all the time, right? So if you have inside information on whether Tay-Tay is gonna be pregnant by the end of the year, you could get in here and bet and make some money one way or the other. But if you imagine there's lots of people in the world, some of them have more knowledge than others, and they're actually betting with their money. You can look at the overall trends and see what is actually happening and what's going on there. So you can learn a lot from these information markets. And yeah, you can bet on these live too as they change. And you can learn how to build your own at speedrunethereum.com. We've got some new ones coming out like ZK voting, oracles, multi-sig wallet, SVG challenge. So Speedrun Ethereum is a great resource. Going back to if you're speaking to someone at the university, you can kind of show this curriculum off. I loved getting in front of professors and being like, hey, what's your Solidity curriculum look like? The Speedrun Ethereum looks a little silly. It looks a little like fun and gamey, but it really is a very serious curriculum, and it's taken years to hone this curriculum to get it where it is now. So yeah, go through it, tell your professors about it, tell your blockchain clubs about it. I'm around. You can find me at Twitter and Telegram and ask questions. We're always adding new things to it, kind of trying to follow the meta, skate where the puck is going, and figure out what challenges to teach people. Again, university@ethereum.foundation is a good email if you want us to come to your campus or if you want to reach out to connect with us. Let's see, next thing I usually do is I go to slop.computer and I talk about why censorship resistance is important. So let's do a vibe check. This is a quick little app that I vibe coded that lets you vote on how's the vibe. So you should be able to shoot that QR code and hopefully you can connect to my server and vote on if the vibe is good or not. So get on in there. I'm not seeing anybody connecting. Maybe the server's down or something. If you scan it, does it take you to connect? Yeah? Okay. There's everybody. Everybody connected. Very nice. Okay, only good vibes. Very good. So this is just a silly example. I vibe coded this. I said, let's ask how's the vibe. Vibes are very good, but there's a reason for that. There's censorship happening here. If you try to vote bad vibes, you get like a system malfunction, right? I'm censoring it, and I'm saying like, no, only bad vibe or only good vibes. And this is just a silly example. I vibe coded it. You could Sybil attack it. I guess we have 72 people connected, so maybe, yeah, there's that many people in here. Usually what people figure out is they can Sybil attack this and just open it up in a bunch of windows and vote too. So there's definitely some elephants in the room with how this voting works in the first place, but the point I'm trying to make here is censorship. In our lives, in our world, we live in a pretty good world. We don't really deal with censorship very often, so it's nice to see an example like right here. Of course, this is a very simple example, but this could be a presidential election. This could be a vote to change the policy that affects, billions of people. And we don't want those kinds of things to live on centralized systems where people can censor them or people can manipulate them. This is a good example of why we need both blockchain but also privacy. This needs to be a private vote. We need to have some kind of identity so you can't Sybil attack it. So there's more than just blockchain, but blockchain is a big piece of this. Okay, usually what I do to finish this is show off Scaffold ETH. Scaffold ETH is a tool you can use to build dApps. I think Shiv's in the audience out there, back there somewhere. Shiv is the main, he owns Scaffold ETH. So when you create a PR or make an issue, he has to deal with it. But the very first version of Scaffold ETH was built by me back in like 2018. It was ugly and gross, but it helped you build hackathon projects quickly. Now, people much smarter than me have taken over and made it very nice code, and it's very smooth and state of the art. But let's go ahead, let's see if I can build something with one hand here. So let's make a voting app just like we did there. Okay, and so I'm gonna do, I just went to scaffoldeth.io. I grabbed the command, it's like an MPX command. Oh man, I'm doing this through my phone too. This is gonna be wild if this works. You have the choice between Hardhat and Foundry. If you're close to the space, you know that Hardhat and Foundry are smart contract orchestration, testing, deploying frameworks. Foundry lets you run your tests in Solidity. It's more of like the cracked devs are using Foundry. I think Hardhat's a little easier for making deployments. Foundry's faster. Hardhat's trying to catch up, but you can use either one in Scaffold ETH. Whether you use Hardhat or Foundry, you're still going to use the same commands to end up doing the deployment. And let's go ahead and also open up Cursor here. What did I call that? Voting app demo. Okay, so while that installs, let's cd into what? Voting app. This is hard with one hand. Demo, yeah, let's go. Okay, and let's open up Cursor. So Scaffold ETH has both the smart contract orchestration and the front end built in, and it has things set up so they're already wired up. So your smart contract is there, but your front end is also there, and your front end is already wired up. So there's buttons that are talking to the smart contract. You're reading with hooks. So this ends up being really nice for AI. Like we heard in an earlier panel, maybe not the best idea to be vibe coding smart contracts with millions of dollars in them, but Scaffold ETH does allow you to one-shot apps. It has a cursor rules, it has everything wired up already with a smart contract. You can even use cursor to write your tests for your smart contract. So you can say, build a smart contract that does this, but let's build like a very elaborate test bench to go through everything. And again, like we heard earlier, I think AI makes a good programmer better. That was I don't know who said that earlier, but it was really good. It makes a good programmer better, makes a bad programmer worse. Like, if you don't know what you're doing, you probably should not be one-shotting apps. But if you do know what you're doing, this is a tool that will help you like 5x or 10x your ability to make apps quickly. So first, go through Speedrun Ethereum, understand the concepts, go to Solidity by example and learn about all the hacks, and implement reentrancy yourself so you understand it. Go through all the hacks that way. But once you're ready, you can build your own apps. Let's do this. I'm going to put the mic down for a second and just type out this prompt. But basically, we want to build that voting app that we just built. So let's see here. We want to, build a voting app that asks, how's the vibe? Answers are good or bad, right? Like, kind of like their buttons. I don't know why I'm doing this like this. And we want to make sure some important things. Make sure there isn't an owner of the contract and no way to reset the vote, right? Okay, and hopefully it just makes the full front end. Maybe I should say something about that. Make a front end that displays the votes and lets people vote. So what I want to do is just like one-shot the app. I want it to do both the front end and the back end. Normally I would probably add in, I don't know, the page and the contract. I don't really need to do this. I think it's in the cursor rules, right, Shiv? I really don't need to do this, but I'm doing it. I'm an old dog. It's what I remember doing. So I've added the front page, the Next.js page, and my smart contract to the context, but it already has that. It's in the cursor rules. So let's see here. Can this thing one-shot a voting app out of the box? Here we go. Let's just send it in. So what this is going to do is it's going to start with writing the smart contract. It's going to help us create a voting smart contract, right? And if we get in here, we can kind of follow along with what it's doing. Scaffold ETH kind of comes with this nice greeting contract. And it has a nice front end that I haven't shown yet either. Let's go ahead and kind of fire everything up. I wanted to do the prompt first just so it has some time to work. But let's get in here and look at what you get out of the box with Scaffold ETH. So you have a chain that you run. So you have your own local blockchain. So it's going to have like free money for you, right? You have your own local block. You have all these accounts with like 10,000 ETH. You can quickly make transactions against it. It's kind of private to you, right? It's on your own machine. You can dink around. It doesn't cost you anything. Then you also have a front end with an app that auto adapts. So as you add new fields and functions to your smart contract, your front end will give you these new buttons.
You need someone to hold your mic?
Oh, no, we're all good. Thank you. I appreciate it. And so, yeah, that was the only mic I needed. I did a little armpit thing. It worked. Okay, so here we're going to get a look at the front end too. And so you've got your back end with your Yarn chain. You've got a front end with your Yarn start. So you've got a Next.js server along with your smart contract orchestration. It's already wired up. It comes with a cursor rules. This is what Scaffold ETH looks like out of the box. You even get burner wallets. So once you get to production, you're going to want to use that Rainbow wallet or a MetaMask. But when you're in development, it's really nice if you can just have a quick burner wallet that has a private key and local storage. And then also you can go to this faucet here too. So we could go to the debug contracts tab and, oh no, look at that. Our voting app is already ready to go. It's just replaced the front end right out from underneath us there. But what I wanted to show is in the debug contracts, which we can't see right now, you get a full UI for your smart contract. And as you add functions to your smart contract, this debug contracts page has this full UI built out, but we can't see it right now because it's already built our oh, don't install a new update right now. Okay, let's look at our smart contract. So it looks like it's asking the question. It puts the question right in the smart contract. It probably shouldn't do that. That's extra expensive. It's keeping track of votes. It's keeping track if you have voted, if you voted for good or bad. There's vote good and vote bad. And then there's these requirements that make sure that if you've already voted, you can't vote again. So it's doing a pretty good job of making sure that this is pretty secure. Of course, I wouldn't run a national election on it until I had like a good audit on this, but it looks like it's pretty good to me. I don't see any ownership. I don't see any ways to reset the vote. I think that we could have some nitpicks here from the auditors earlier about gas usage, but in terms of if we get rid of the civil resistant problem and the privacy problem and just focus on would this work as a vote, I think we would be successful. Okay, so let's go ahead and deploy our smart contract, yarn deploy. And so that will deploy our smart contract to our local blockchain. It may have already done it. Let's see what it's going to do. There we go. And then we can go back to our front end there, and there it is. So we can see the results. We can click vote here. Let's see, can I go to the debug contracts? This is what I wanted to show earlier. It's just like whatever functions you have in your smart contract, it lets you do your read functions, your write functions. So as you're kind of just learning Solidity for the first time, you can always just get in here and tinker around. You can add new things to your contract and poke buttons and try things. And this is nice little interface will just change as your smart contract changes. But we went straight to one-shotting the app. Here it is. Let's see if I can vote good or bad. Either one should work. Here I can do a new, this is an incognito window. So, and this is a different wallet, right? If we go look back there, this is kind of like pink and purple guy. This is kind of like blue and teal guy. And let's make sure he can vote bad, right? We've already got the results from the good vote. Let's make sure the bad vote works also. You'll notice there's no pop-ups here asking me to sign transactions or anything. That's the beauty of burner wallets is it's signing all these transactions in the background and just letting you kind of click buttons as you want. But we're able to vote good, we're able to vote bad. So our app is basically ready to go. The next step would be deploying this somewhere. So if we wanted to put this out on an L2, we might do something like Network Arbitrum or Network Base. And then you'll have to create a generator account. You do like a yarn generate. You fund it with some money. I can do that in a little bit if we need to. I think we might be running out of time. This is kind of like my full demo for a university. We start with kind of going through the what is Ethereum, how do you learn more about it. We teach people how to get Ethereum, get a wallet, what a 12-word seed phrase is, how that works, better ways to custody your funds like a multi-sig, and then kind of what kinds of things are actually working on chain right now, like stable coins, RWAs, lending, borrowing, like prediction markets, ZK voting, oracles, and then just like how to go learn all that stuff. If you're a developer, you can go to speedrunethereum.com. All of this stuff is free. All of this stuff is in GitHub. We don't even collect your email address. If you want, you can connect your wallet and you can turn in, as you go through these challenges, you can turn them in and we run tests against them and give you a credential for finishing them, but you don't have to if you don't want to. You can just get them on GitHub and go. Then I go through the vibe check of, not only is this vibe check censored, but it just lives on a server somewhere and I could go reset that server and the vote would also reset. And then we go to the how, like how you go about building something, how you get started tinkering, and that's what scaffoldeth.io. If you're going to a hackathon, which I recommend you doing, once you get started and you get pretty good at building, you should go to hackathons and you should build a bunch of things. It's really important. You're wondering, like, what is my next step? I know how to write a smart contract. Your next step is to just build a shitload of things. You should build a bunch of things and show off. Build a bunch of things and show them on Twitter. Today I built a DEX. Tomorrow I'm going to build a prediction market. The next day I'm going to build a stable coin. Build them and show them off and repeat. Build a Twitter audience. Build up your own knowledge. Force yourself to deploy to mainnet. It's very scary, but do it. Even if it's just like a mainnet L2, like Arbitrum or Base, it costs a fraction of a cent. Deploy it. Go through the lessons of learning. And I think that's about all. I could deploy this live, but I don't think I need to. It's just a couple of commands and it goes on to an L2. Maybe questions or anything else? Anybody, just in general, I'm Austin Griffith. Let me show my Twitter. This dude here with the bow tie. Should have worn a bow tie today. What was I thinking? This dude here, I'm at Austin Griffith. My DMs are open. It's the same exact handle on Telegram. If you want to reach out on Telegram, I'm just at Austin Griffith on Telegram. DMs open, always looking to talk to more people, especially if you have a university or a blockchain club and you'd like to go teach them and you need the resources, you'd like to talk to your professor and you need more curriculum, or you'd like us to come visit your university or do a virtual session, we're available to do that. Thank you. I'm Austin at Ethereum. Reach out if you have any questions.
Thank you so much. One more time, round of applause for Austin. Wow, a technical demo with one hand and nothing went wrong. That has to be my top 10 moments as in the audience. That is amazing. How many of you in the audience are students here? Students, raise your hands. Wow, you got a live demo from Austin and a live session from Vitalik. I am so jealous of you all. Awesome. We are not done yet. Next up, we got Prabal talking about roll up the sleeves. I love that title. Prabal, do we have Prabal here? All right, round of applause for Prabal. All right, when Prabal walks up here, we'll set up the slides back up. Here you go.
Thank you.
GM Prabal.
Thank you, GM.
So let me introduce Prabal first before getting into the fireside chat. So Prabal happened to be a PhD dropout from ISI and co-founder of Avel. So I'm just mentioning PhD dropout. So
That cannot be my identity, and especially when I think he asked how many of you are students, and so many of them were all students. Don't take me as one of the inspirations.
Okay, fine. So Prabal, how did you start with the Web3? Let me start with a very simple question.
I think I was doing my research in blockchains and mainly on cryptology and security from ISI, and that's when I started delving into blockchains and such, and quickly realized that it is something which takes a lot of ideas from different kind of verticals of education and then combines them together to create something phenomenal. So yeah, that dragged me in.
Actually, you started applying your research and you ended up in the industry.
Yes, I think while writing all these research papers, I quickly realized that although I think I have a lot of great ideas, but I don't think many people are using it, and that kind of led me to believe that, and I did some industry internships and such, and that led me to believe I should be doing something there.
That people builds on rather than on the
it's just there is this itch of people using whatever you have proposed. I think that is taking over.
Well, that's a great thing. So okay, let's move our discussion on to rollups. Okay, like, what do you think about the ZK rollup versus optimistic rollup debate? Like, I want to pinpoint on the part that these optimistic rollups are as a drop-in solution because we couldn't come up with a ZK rollups at the time these rollups concept is proposed. So, do you think optimistic rollups being completely overshadowed by the rise of ZK rollups soon?
It might happen in the long enough run. I agree with you. Like if we take this current movement long enough, I think everything will be zkified. I think Vitalik gave very compelling reasons of why it is going to be the case, and many others have been working tirelessly to make zk commoditized. And when zk becomes commoditized, then there is no reason as such not to use zk rollups and still keep on using optimistic rollups. I think today it is not the case. So and I would love to go a bit back, right? Like when Arbitrum proposed the original paper, right, and all that, it was fascinating because there was no zk solution. Like the practical zk solution of a general purpose rollup was not possible at all. And many people, including us and some of the audience I know, also tried doing ZK, like general purpose ZK rollups at that time, but neither the tooling was good, nor the performance was good, nor the architecture was good, nor the compilers were not good. Like it was not what it is today. And so it is easy for us to say today, but at that point in time, optimistic was the practical solution, not just a drop-in per se. But over time, I think ZK has taken over like a lot, and like I have been only in the grand scheme of things, ZK as a theory has been since 1980s, right? The 1986 or something, I think the papers came 1984, 86. And since then, a lot has happened till, let's say, 2020 or so, when like 2016, when I started my journey and such. A lot has happened. But from 2016 to 2026, let's say, the increase and the performance increase have been like just huge.
Yeah, I agree. Like after focus of like these blockchains on the ZK part, the ZK research acceleration that happened is like very humongous.
Yeah, no, I think I was just talking to a peer of mine again, did his PhD and now he's doing a postdoc and so on. And he was writing a research proposal on ZK. And we were just brainstorming, that what are the top kind of applications that you can show. Blockchains, authentication. Like apart from that, yes, there are a few of these applications out there, but you cannot show that what impact it had. Like if you have to talk about raw numbers, the number of people using a Google Wallet is just huge. And them using ZK Wallet, ZK tech that's why it's so huge, right? And similarly for Ethereum, every other.
Well, it's true, but Google has the distribution that it built over like several decades, and we are at the very starting stage of the ZK era.
No, absolutely. I'm not competing. I'm just saying, like, these two are the landmark places where you can show impact of ZK. Although ZK has been around and in different shapes is being used in many other applications.
Yeah. So following up on this, so data availability has been a thing, as optimistic rollups need some sort of data to be provided during the fraud-proof stage. So the fraud-proof bisection game can be played out, and any malicious execution could be figured out. So if the transition from optimistic rollups to ZK rollups happen, how do you see data availability coming into the picture there?
So I think there are two things of a rollup, right? You need to have liveness and safety. So in optimistic rollups, both liveness and safety are at risk when DA is not available. People think like, for ZK rollups, DA is not that important. It is still important because liveness cripples if you do not have data availability even inside a ZK rollup. So what can happen is, although your funds are safe, a ZK rollup protocol ensures that no one can spend your funds unless you have signed it. But it still doesn't give you a guarantee that you will be able to know your current state, you will be able to know your trace, you will be able to know your account structure at that point in time and so on. So you can have frozen wallets. So it's like saying like, I have this account in a bank, this bank is all good, but the branch is closed. So it is not not that helpful to have all this money in that bank account.
Yeah, it just gets more like, you know what, this thing works, but I can't use it.
Exactly. So you can have frozen assets on ZK rollups.
Well, I get it. So maybe this is something interesting that I also wanted to ask you from long time. See, we have seen a lot of interest over CLOPS after the success of Hyperliquid. And there is this discussion happening on CT saying that data availability layers play a huge part over bringing faster confirmations for the CLOP dexes that are being built. What's your take on it?
I think it's true. Like, there are, again, it's true to a certain extent, right? Let me talk about the long-term goals and then the short-term realities, right? The long-term goal is true that the only level of finality which matters is the base layer finality. So even if you think of it today, like when I think a few days back there was this huge thing about tempo coming in and so on, right? And one of the major discussions about it was like, why doesn't it run as an Ethereum L2 and so on? And then there was this big discussion, and a lot of discussions happened.
CT purity checks.
Yeah. And then one of the things that L2, if you talk to the L2 teams, one of the things that they want from Ethereum is faster finality.
Yeah.
Because that is one of the major bottlenecks of getting very, very good security guarantees and experiences for the rollup users also, right? So, and this is for general purpose rollups, I'm saying. DEXs are no different. DEXs also, if your base layer gives you very good finality guarantees and very quickly, then all your not only order placements but cancellations and such will be ordered and finalized extremely quickly, which means all the guarantees up top are just so much better. Yeah. Now this is the long-term thing, right? So that's why I think that it is important for DA layers to have very high finality guarantees and such, because they essentially act as base layers. The second thing is, do you, like, one of your probably a part question is it even needed for CLOPS to be over DA layers themselves? That is, again, if you think about every one of these rollups, if all of them become general purpose, then there is no moat.
Exactly.
Right? How many bases can be there? How many Arbitrum can be there? How many ZK Sync ERA can be there? How many Polygon POS can be there? Right? So there will always be a power law effect, which means that you really need to go for app specificity, and that's what a hyper liquid, particularly, not the EVM side, but the Hyperliquid has shown that it is the app chain, and that people have followed suit, like a Lighter, a Hibachi, Aster. They are all kind of DEX chains, right? They can do general purpose stuff, but they are known for being DEXs, and that's what it will happen. That even if you take this multi-chain theory and this L2 theory to the extent that you want it to be commoditized, it will still be application specific. They will not be general purpose.
Got it. So as we also touched upon the app chains part, so if we actually look at the current scenario versus the ideal scenario that's proposed few years ago, we should see a lot of app specific chains here, but which apparently that we have only few app specific chains surviving. So what do you think that caused this app-specific chains to be less compared to the general purpose chains?
I think, throughout history, Cosmos had this app chain thesis. This app chains were, kind of, again, I don't know whether there are Cosmos maxis here, but I will still say it, that they were kind of, they were fighting amongst each other because the bigger ones always thought the smaller ones are going to be parasitic on them and so on and so forth, because there was no shared security notion. Yeah. They tried a lot with the Cosmos Hub and such, but that didn't work. Now, if you think about the Ethereum's rollup centric thesis, it kind of lays down that there's a base level security, and then there's this kind of vertical scaling kind of concept, right? That this L2's kind of scale. And on that, why is it happening that app chains are not so-called surviving, if as the OP proposed? I think it's a tug of war. It's a tug of war and a tug of power as well. You start with being app specific, then you start seeing see Hyperliquid, for example, right? They started app specific, but then they shown like, okay, I am app specific, but I can do only a little.
Yeah.
Why not I make this I make this kind of as a
Extendable
service
to a general DeFi thing and
exactly
came up with Hyper EVM.
why can't I also have something else? Why can't I also have some other protocol? Can I have lending on top? Can I have dexes, other dexes?
Yeah.
The core writer thing that Hyperliquid community is working
Can I
on
have
and so
other
on.
people offer perpetual services using the HIP3 like the
Exactly,
HIP3 thing?
exactly. So those kind of things is slowly going on these communities, and that's without it's not without any good reason. Now what will need to change is, if you think about it, if a good protocol could have interacted with, let's say, Hyperliquid without having to build on the Hyperliquid EVM, that would have changed the game. So if you think about it, the app-centric, the application roll-up thesis cannot go isolated.
Yeah.
It has to go with synergy with others. The same Cosmos Hub realization needs to be done in some other shape, of course.
Yeah.
And that's where, for example, the Ethereum Foundation is working so hard on a UX focus, which is centered around a common shared, I will not call it an interop standard, but some way to do interop within all of this.
Somewhere to communicate between
Somewhere
all
to
the
communicate.
existing
And if you think about, all the rollups on the Ethereum ecosystem, a bulk of them are, OP Stack.
Yeah.
And if you talk to OP Stack team, they have the similar vision that, a Uniswap is going to be their central DEX. So all the exchange for all the swaps for all their chains within the superchain ecosystem are going to use Unichain.
Exactly.
Right? So but that has not happened because the interop is not in there today.
Yeah.
But if it was there today, it would have been enabled.
Well, I agree with you. Like the interop product is a bit still in the cooking from the long time, but I can say that if interop is like getting really cool and fast with a stronger security guarantees, then we might see future where there are more app chains than general purpose chains. So my next question would be on the interoperability, like the Avail Nexus that you guys are building. So how are you planning to build it? Like, is it the base layer is the DA1, on the top of it you are building the interop product where we prove that something has happened, like the transfers from one chain to another chain. So could you please add more information on that?
Yeah, so think of it like we wanted to solve scaling because all these app chains cannot work if there is not a scalable layer behind it. And that's where, our Avail DA completely focused on. But as we just discussed, right, if what I said kind of made sense, then it made sense that all our partners and the broader ecosystem is struggling with the fact that how can they talk to one another.
Yeah.
And most of the talking today, I think more than 99% of in value happens over fungible tokens. So we were thinking of how we can do that natively inside the Avail ecosystem and beyond. And that's from where Avail Nexus kind of came in. It is essentially a way, you can think of it as a class of protocols with multiple security modules which can be plug and played. And each one of them is on the developer's choice on which one they take up, how they actually work on it, and so on. But ideally, we want to abstract all this chain-specific logic. We want to have a world where a person just goes and uses an app. This app can be any app on any chain.
Yeah.
And their wallet can be having funds on any of these chains lying around, right?
Yeah.
And we want to be able to still use that application without having to think about how do I need to bridge, which asset do I need, is the application secure, and things like that. Application security, of course, is important, but the bridging security is not.
Yeah. So got it. So interoperability is where Nexus focuses on, and you guys would be connecting all the apps that are part of Nexus or not part of Nexus and make the interop solution work. So let's say we are recently seeing a lot of enterprise announcements coming in Web3. Like they are huge, like the Robinhood thing or else the Stripe thing that they are doing, Tempo with Paradigm and all. So when these enterprises come in, they also have this own criteria that there must be some sort of privacy over the data that they are being putting upon. Like Tempo, we can call it a blockchain, but they have their own limitations over who can see the data or else who can produce blocks. And for Robinhood, it's being again Arbitrum rollup. So how does Avail adopt in with the Enigma and provide confidentiality to the data availability layer?
Yeah, so again, very well put. All these enterprises, I mean, even before Robinhood and others came in, right, all the banks and such that we were talking to, they wanted definitely to have privacy, because there is no world in which they are going to expose their user data to the broad world because of the financial rails that Ethereum provides or any of these blockchains provide. So that's why it's important that we think about these confidentiality in various different ways. One can be, pure privacy based. One can be just confidentiality, and there are some nuances here and there about what each one of them means. But also on the application layer, it can be private. On the data availability layer, it can be private, and things like that. We have a data availability confidentiality solution that we call as Enigma. This Enigma kind of encrypts the data and then puts it on the DA layer while giving guarantees that the original data is still available, right?
Yeah.
So that's the kind of guarantee that we provide. Application level, confidentiality is something that they still have to cook up.
Yeah.
But in the L2 sense, this becomes easy. For example, if a bank uses their own roll-up, they are not, they can have their own sequencer. So they are not having to expose any transactional data to anyone else, while it needs to provide the DA guarantees for anyone else to take them seriously, right? For anyone else to check a ZK proof that all their transactions were done correctly, they need to know that the data is actually available, right? So that we can provide using Enigma. So there is application level confidentiality, and then there is DA level confidentiality.
Well, this seems like a perfect solution. So my next question will be, as we are talking on to sequences, and if you guys are following the CT, the base debate that's happening that a centralized exchange can't have a roll-up which can actually fuck users up by just putting a state root, which is not true, if I'm like catching the debate entirely correct. So what's your comment on that? Like people are on the both sides, like calling a centralized exchange then a centralized exchange can run it and say they won't be compliant just because they're running a sequencer by themselves, and few people support it and few people doesn't support it, and few call incremental improvements over the security will result in better outcomes. So what's your take on this?
So there are again, you have to see two sides of the story, right?
Yeah.
The one is on the UX side. So if you have to give absolutely amazing UX, and you have to compete with all the centralized exchanges of the world, then you cannot be doing decentralized sequencer and consortium and quorum and things like that, because in any system, compute versus network is going to be slower than compute, right?
Yeah.
So it is simple to kind of say that centralized sequencers are going to give better experiences than just decentralized quorums. Now on the other hand, because they're all stage 1 and all that, I think they have very good guarantees of what it means to have a centralized sequencer, which means that they cannot censor you. They will have, you will be able to exit, you will be able to enter the system through forced transactions and such. So Ethereum by default, and because Base conforms to that, they have a very high standard when it comes to classical security. I think what we now need to get into is essentially things like MEV, right? MEV, or ordering of transactions and such. There, I think it's their credibility which is at stake, right? Yeah. So it is, because Coinbase is so big, if you think about it, I mean, I don't know whether people here realize like how big Coinbase is, unless like, you see the US folks just going gaga on it and the amount of volume and such. I think if you look at any exchange which is accepting from Base, if you look at any bridge which is connected to Base, you will see like almost none of them wait for finality guarantees. Almost all of them just take the sequencer guarantees and run with it.
Yeah.
That is the amount of credibility that Coinbase has been able to, have. It doesn't, like, of course, there is a risk to that. The risk is that and this is a classical cryptographic attack that you do in reputation systems, is that you gain reputation and then you slash it, right?
Exactly.
Right. So that can happen, but and in that time, if that ever happens, then there is so much more to lose than just one transaction fees or just one trade or just one liquidation or whatever, right? There's so much more at stake, and this is classical proof of stake. Why does proof of stake work? It's similar, right?
Yeah.
That there is so much at stake that you will not do anything malicious, right? And similar things again in different forms, of course, are there with Coinbase. So is it the best kind of thing to do from a cryptographic perspective? No. Is it a good thing to do from a user experience perspective? I would say yes.
Yes.
Is it a good choice to do today in the current grand scheme of things? I would definitely say yes. But should it be the same, let's say 3 years later? I don't know.
Maybe no.
Maybe not.
Yeah, I get it. So the reputation of Coinbase that's at stake is what we need to consider. And well, it works for Coinbase, but not for every other company or else every other centralized exchange that launches a new roll-up where they have a DEX organized.
And that's happening also. Like again, with every good thing, there will be like multiple bad ones, right?
Yeah.
So there have been cases where roll-up funds have been completely gone. There have been cases where every exchange is now considering a roll-up of their own and so on. And that's a good thing and a bad thing. And we will see.
Yeah, I won't get into Binance. Yeah. Okay, Prabal, I think we had a great chat about rollups, data availability, and how Avail is going to give confidentiality for enterprises. It's nice having you here, and I hope you have enjoyed the chat. And also, if you want to if anyone in the audience want to talk to him, he'll be available on the sidelines.
Yeah. Thank you everyone.